Good afternoon, everyone.
Thank you.
My name is Vijay Solanki. I am from Bradman Engineering. I welcome all of you to this technical webinar dedicatedly designed for steel mill roll shop. We sincerely thank you for your participation. Today, our panelists, Mr. Thomas from Nextsense, Austria, and Mr. Andrea from Atomat, Italy, will be presenting two interesting technical presentations. We are sure this webinar will be beneficial to all the attendees here coming from roll shop across India. In case of any queries or any questions, you are requested to drop in your queries in the chat box and we shall revert back to you shortly. You will also get an opportunity to interact with our panelists directly at the end of each session. Going forward, I welcome Mr. Thomas from Nextsense. Mr. Thomas will be presenting the usage of lasers for measurement of roll gaps and roll grooves. Over to you, Thomas. Welcome to the webinar.
Hello, thank you for the introduction. My name is Thomas. I'm from the company Nextsense from Austria. Nextsense is a company that makes laser-based measurement systems. And we do that for different industries. Our main industries are railway, automotive, and steel industry. For the steel industry, we do several measurement tasks, mainly for hot rolled long products. We do profile measurement, we do surface defect detection, flatness measurement, and for the roll shop part, we also measure roll grooves, roll gaps, and roll stands and their setup. To go forward, I want to present to you today our C42 measurement device with the roll groove measurement. And for that, I'll start with a short, brief presentation about our product and the technology we're using. I'm sharing my screen. For you?
Yes.
So we have a device called C42. So that's the name of the device. We call it Calipri C42. It's for detecting roll wear, gap measurement on roll stands, optimizing roll setups, roll groove measurement, and comparing the results to the optimal measurement, to the optimal shape that you want to have for your rolls and roll grooves. So our motivation for the system itself was there are still mainly quite old techniques used to measure roll wear, to measure on the rolls after they are used. You either use depth calipers with or without rulers together, or you make negatives out of wood or some other material and then use feeler gauges to find out how much wear you had and at which position you had how much wear after using the rolls. And we have a contactless laser-based measurement system that can provide the same measurements, very easy to use with portable system that you can use all over the mill, in the roll shop, on stands that are installed. So that's quite a huge improvement to those older methods of measuring roll grooves and rolls itself. So the technology that we are using is laser light section. So on the left side, you see we project a laser line on the object that we want to measure. We capture the laser line with the camera, and we get exactly only the picture of our laser line out of that. And with that information, we can get profile information, a shape information where the laser line is on. This is the overall laser light section technology. We use a patented principle of this, which we call Calipri. That's also why the device is named like that, where we're using 3 laser lines, not 1. And we're using 3 laser lines to be able to correct tilt and roll. And that enables us to provide devices that can be moved freely with your hand around without losing accuracy. So when you move freely around, we use the outer 2 lines to correct a tilting or a roll effect that you can have when you hold the device not straight on the object that you want to measure. And therefore, it's still easy to use, although you can use it completely freely with your hand. So what we want to do with our device is capture single roll grooves, measure full rolls from different angles at different positions, transfer the data to a tablet PC, have an evaluation there, show you the results of your measurement. So how deep is your roll? What's the width of your roll groove? And also compare it to the optimal shape to see where the deviations are, how much wear you had after using your rolls, or also before using the rolls to check if the shape, the contour is at the perfect state that you want to have before using the rolls. So the applications that we have here is, first of all, detecting roll wear by measuring rolls, roll rings, before usage, after usage, to see how much wear you have at which parts of each of the roll grooves. The second part would be to have a complete control over your roll stand. So to check if you're aligned correctly, if the gap on the left side, on the right side, and in the center is the same. And also to check how much the distance is between the top groove and the bottom groove. And as a third part, it would be profile compare in the software that checks how the measurement looks compared to your optimal measurement, to your optimal shape that you want to have for a certain roll, for a certain groove. Here are just a few technical facts. Just point out the most important ones, which would be the absolute accuracy of 80 microns. We have a tablet with the system where the data is transferred via Wi-Fi. And you see the results directly on the tablet that's delivered with the system. So you can measure on-site in your roll shop or even for installed stands, and you see the results immediately. You don't need to go back to your office or some other working spot where you need to evaluate the data. You see it immediately on the tablet on the screen, and you can immediately find out results from the measurement. You're also able to export the data afterwards, so you can use our measured shape as a DXF for deeper analysis afterwards if you want to do more technically in-depth evaluation later on. Here's just a short overview of the whole system. So one part is the device itself. You see that afterwards I do live measurements here in just a few minutes. You see our case with the tablet PC in there, calibration piece, and the device itself. And on the other part, on the tablet, you have the software where you immediately see measurements. You see the shape of the rolls, of the roll grooves that you've measured. You see immediately measurements done there, and you can compare your measurement to the optimal one. So the advantages of our device are: we have a precise and reliable measurement device that you can use portable with your hands, completely free moving on the roll shop, on installed stands, on stands when they are removed from the production line. You get an instant gap measurement. You have better control over your roll usage time because you can determine exactly how much wear you had and where you had the wear inside the roll groove, on which parts of the groove. It's an easy to use device, and you can measure different sizes and shapes. So it's not limited to, for example, only small rolls. You can also measure big rolls with it, full rolls, single roll grooves, or a complete roll. So now I would like to switch over to the live measurement part. So first I will show you how we use our device, how we do a measurement, and afterwards I will show you how those results look like in our software, so you can also see what a user would see when he's using the device to do measurements. So this is the device. So you see at the front here, we have a opening for the camera and an opening for the laser. And you can move that freely around while measuring. And here we have just a sample of a roll made out of wood. And I just show you now how a measurement is done. So you will also see the 3 laser lines here on the object. And I'm moving alongside there. And when I'm done with the measurement, I click again on one of these buttons on the side of the device, and I get the result immediately on the screen. We will take a look afterwards at the screen to show how that looks like for you as well. But first I want to do 1 second measurement to show you how to measure, for example, small roll rings. So when you have, for example, a roll ring here, measurement is done quite fast. So this is all you need to do for a measurement. Takes roughly a few seconds for a roll ring. For a full roll, depending on the size, you usually need between 5 seconds up to 20 seconds to do 1 measurement. So it's quite fast and you get the results immediately afterwards. We'll also show you how we do gap measurements between 2 rolls. So when you have a roll stand setup where you have a top roll and the bottom roll, you measure from the side and you do get the distance there. And that measurement also only takes roughly 5 seconds to immediately have a result on your screen. So now we'll go back sharing my screen and showing you how that looks like in the software, that you also can see which results you can expect from our device, which results the customer can measure with our device. So here you see a screen of our software. We have several measurement points on the left side. And I just start a measurement so you can see how that looks like during a measurement and also how the results look like afterwards. So when you start a measurement there, you can move alongside the device that you want to measure. And then you end the measurement and you get out the results. Just a second, I captured too much of the table. We move over there again, just redo the measurement. You see here the results that you get out of it. So each groove is calculated separately. So you get a maximum depth and a width for each of the calibers. You can click through them one by one, take a closer look, and also see our single measurement points that you see there. And you see the overall shape of the full measurement that we took there. And I want to show you a few different results of different measurements that we can take. So first of all, I want to show you a full roll stand, how that looks like. So here we measured 1 top roll for a customer. So you see the different measurements here. We measured the bottom roll as well, which has roughly the same setup. Then we also measured the gap between 2 rolls. So you see here the blue line is the measurement. The gray line is the extrapolated rest that we didn't capture. And then we get a measurement of the minimal distance between the 2 rolls, the top and the bottom one. And we do also get a calculation of the distance between the maximum depth of the top roll and the maximum depth of the bottom roll. So actually from this position here to the second to the bottom roll deepest position with the gap between the two rolls, and therefore you can determine if your distance between your rolls, between your roll grooves is correct before using them, before starting to roll with those roll stands. You can measure small rolls, you can measure big complete rolls. So I show you one part here where we measured a bigger roll, so with a lot of grooves in there. So you can start from one side and measuring over the shape of the roll, and you would get something like this, depending on how much information you want to measure at once. So you can start on one side, measure over there, or you can only measure a single groove as well. That depends how you want to use the device, how much information you want to get out there. I would like to show you bigger rolls. So this is, for example, a roll for rolling rails. So you can also measure bigger rolls. So it's not only limited to small grooves or small rolls. If you measure bigger sizes, you start at one side and you need to move a little bit further with your hand to measure the full rolls, of course. But you can measure small sizes, you can measure big sizes. With the same device, with the same software, with the same setup, there's no real limitation about how big it is or how small the roll groove is for the measurement. So now I want to show you how we use the compare feature to compare an actual measurement with an optimal shape. So in this case, we measured a worn out roll from the customer, and we measured a new roll from the customer. And here you see those two measurements are aligned over each other. It's also possible to align a drawing that you use instead of a second measurement. And here you see how much deviation you have between the measured roll and the optimal state, or the drawing that you've loaded in. When you move over there, you see exactly how much wear you had at which part. You can make those lines smaller or bigger. This is just for an easier view, so you can make them smaller. And you can color them in red and green for inside tolerance and outside tolerance. For example, I'll make that bigger again. You see here in this area, we have certain parts which are where the lines are red and certain parts where the lines are green. So that means those are inside the tolerance. Red areas would mean outside of tolerance, which can be set by the customer, of course. And here you would see with one view how much wear you had, where exactly the wear was. So you don't only get a measurement in depth, for example. You see exactly on the side, on the flanks, how much wear you had at which exact part of a groove. So here you see another example where you see not so long used roll, where you just see the starting wear on certain spots. And then you can determine if that wear is still okay. You can use it further on, and you have saved information, saved data, which you can export, which you can use on your own. You can save and store on your own for further use. So you know how much wear you had in the past, how much wear you have at the moment for certain rolls, for certain stands. And now just going back to also showing small measurements, roll rings, for example. So you can measure quite small roll rings as well, so with 1.5 millimeter in depth, for example, or roll rings with quite small grooves. And you still get the same information. You can use it in the same way, determine how much wear you had on the small rolls, on the small roll rings as well. Here are just some examples of roll gap measurements. You always see the top roll and the bottom roll, and then the one distance, the minimum distance between the two rolls. So I would like to also show you how a measurement of a small roll ring looks like in the software. So that's actually all the measurement, and you've seen now we've recalculated the results here. So it takes roughly 1 second to make such a measurement because the full roll ring is within our measurement field. The device has a measurement field of 150 by 150 millimeters. You also see that when I make a measurement, you see that triangle, the red triangle for the measurement. Just open an empty plan again to show you how that looks like. So you see this triangle here, and within this triangle, you can move closer or further away from the object that you want to measure. You can move on the one side or the other side. And you afterwards get the results in there. So it's quite easy to use. The user immediately gets a response from our system to see if the object that he wants to measure is inside his measurement field, or if he needs to move further away or closer to it. So it's very intuitive, it's very easy to use. Our usual customers, all the guys in the roll shop, use the device to measure the rolls, to measure the wear, and to also save and document the data. So not only to write it down if it's okay or not, but you can reopen the data, as I've showed you for previous measurements. You can use the data later on. You can export those measured shapes here and use it for deep analysis with your technicians to maybe improve the rolls, to improve where the wear is and where it should go in the future. So this tool can be used very easily to get more information out of rolls that you want to use, or mainly rolls that you're using or were used already. So this is the main part about how we do measurements, how the results look like. And the device is quite small. You usually get a tablet with it. Looks something like this. So it's just a Windows tablet where our software is running on, and you immediately see the results here on the touch screen. You can use it in the steel mill. It's designed to be used in rough environments. You can see immediately after measurement the same results as I've showed you today. And therefore you get a fast, immediate response on the wear of your rolls, on your roll stand setups, and can improve the usage of your rolls, of your overall process, when to change rolls, how long to use them, where the wear is occurring inside each of the grooves. Okay, this would it be from my side. Now we will turn to a few questions that were asked, and I just need to check the questions that occurred were mainly written. So the one question was the price of the measurement device. We will very happily provide you with quotations for the device. Please contact your sales person from Nextsense for that. That can be done quite fast. Yes, so we can also share afterwards, of course, the catalog for it, also results of what you can measure exactly. We do also have videos of how to measure, what is exactly measured, and you can easily view them on via YouTube. We will also share the link after this webinar. And there you also see the measurement inside a roll shop, so not only as a presentation in an office, but inside a roll shop and how we do measurements there. And it's quite useful to see that how it's done on a roll stand for real rolls in a roll shop. So one more question maybe. I was asked if it's possible to measure cracks. If the cracks occur exactly where I start my measurement, I do also see them. You see here, I can move these apart, and you can actually also see exactly that that gap. Maybe I just share my screen once more to show that to you. So exactly here, you would see that gap that is shown here, where I can move apart my test roll that we made out of wood here. So you would see cracks, but if they're on the other side of the roll, you don't see them. So we do an actual measurement on one certain spot. So we do not check the full roll all around and find out where cracks are, for example. So another question would be the minimum and the maximum distance required for measurement. So the measurement field is 150 by 150. So that's also the distance that you can use. If you're too far away, the red triangle would be empty, and you immediately see you're too far away. And when you get closer, you start seeing the shape that the laser is on. You can go as close as to 20 millimeters to the object that you want to measure, but usually you have an average distance of 100 millimeters between the device and the object that you want to measure. So for flat rolls, you cannot use this product. It's quite important also to point that out. We are capturing the changing shape of the object that we measure to the fact that it changes while we move around. When we measure a flat area like the table or a flat roll, it's not changing. And we do not capture how fast you're moving around with the device freely by hand. So we cannot know how fast you're moving or if you're moving really slow over an object. So we do need a change in shape at least every 150 millimeter to get a correct measurement out of our device. When you only capture a straight line, we would not finish the measurement because there is no deviation in our result. It's only always the same, and we don't know how fast we are moving around with the device. So there are a few more questions. We will attend to those questions either in written form or after the webinar, because I want to shift now back to Pradman Group and also give over to Andrea for the second part of the webinar, because our time is already up. But I will save those questions and we will answer them either in written form in between or after the webinar. All right. So I would like to give back Vijay. Thank you.
Thank you very much, Thomas. And it was an interesting topic which you have covered during this webinar. All the attendees, we have many questions from your side, and we shall definitely revert to you one-on-one after this webinar. Thanks a lot once again for participating into this laser measurement. I would now request Andrea from Atomat, and Andrea will be presenting the best practices of machining tungsten carbide rings and rolls. Over to you, Andrea.
Thank you, Vijay, and hello, everyone. Thank you for joining this webinar. I am Andrea Colussi from Italy, from Atomat sales department, but I worked many years in past in the technical department and in the service department. Therefore, I think many of you discussed with me something about our machinery, our products. And also I met many of you in person, I think. What I want to talk to you today is the best machining practice of tungsten carbide, with of course with the CNC machine and with our tooling, with Atomat tooling. I share now the video. 1 second. Okay. Okay. Let me. Okay, tungsten carbide. Now we are speaking about tungsten carbide specifically for hot rolling mills like yours. But of course, tungsten carbide has been used in past for many applications, for very many applications since the mid of the previous century. About rolling mills, of course, the tungsten carbide has been defined by its grade. The grade of the tungsten carbide is mostly defined by the grid size and by the binder, so by the cobalt mainly and the nickel that are inside that keep the tungsten carbide together. For the hot rolling mills, usually the binder percentage are between 20, 25, and 30. I'm speaking about the finishing stems for composite rolls. But when you go in the wire rod, also in of course in the high speed finishing block, here you have rings also with lower percent, so high hardness of tungsten carbide rings that can reach also 15 or even 10% of binder. And why speaking about binder? Because of course tungsten carbide must be chosen also as a compromise between the groove life and also is machinability in the road shop. I mean, when you are in your road shop, of course, you must decide how to manage the machining of the tungsten carbide, and also sometimes you face huge difficulties if the material is too hard to be cut. In fact, when we speak about the maintenance of these rolls, we are speaking about both composite rolls, composite cylinders like this one in this picture on the left side, but also about the rings. And therefore, the main attempt usually is to go by turning because in road shop you have many turning lathes that are ready to be used, but sometimes this material is so hard that it's not easy to be cut by turning. And also sometimes the machines are copying machines, maybe with some problems with some play on the axis, and do not allow a perfect turning of this material. The classical problem that I found when I travel to our customer is the width of the grooves. I'm speaking about grooves like this one for a bar mill or a bar mill, where with the old lathes and cutting hard material like this one, the width could be lower than the nominal size that you require. And therefore, when you go to notching, when you go to make the ribs, you have more material on the side than on the bottom, and you face really tough times to notch these rolls. This is also why we are here to analyze the main factors that affect the tungsten carbide processing, and also the choice between what kind of process to apply for machining these rolls. The three main factors are the CNC machine, of course, so what kind of machine you will choose, the tooling that we will use with this machine, and last but not least, the cooling system that will be very important to cool down both the material, so the tungsten carbide, and also the tool to preserve its life. Between the CNC machine and the tooling, there is a fourth important factor that are the parameters that you will use for cutting the tungsten carbide. Parameters that are just a suggestion usually Atomat gives to their customers, but after that, the customer will find with the times the perfect parameters to balance, to balance the tool life and the time for machining the tungsten carbide. What kind of process gives the best results in at this point? Turning or grinding? We know that we can use the turning lathe or the grinding machine to cut the tungsten carbide, but it's important to understand what is best for your plant, because it's not always on one side the response to this question. At these days, usually, and with an CNC machine like a machine, an Atomat machine, the answer usually is in the middle, as I told you, in these two machining process. Both a solid, sturdy for guideless lathes and also a tungsten carbide, of course, grinder are perfectly capable of machining WC. I call it WC in place of tungsten carbide rings and rolls. Surely, we have to say it's important to take also in account the additional and specific elements that make the decision easier, because when we suggest a new machine to a new customer, to an existing customer, we just say, we do not just say, okay, go for this or go for that. We analyze what is the past design of the customer, what are many factors that can result in one of the two. These factors, these elements, mainly are the grade, the geometry, and the mix. The grade, as I told you before, is the percent of the binder that makes the hardness of the material that you need to cut, the hardness of the tungsten carbide. As I told you, usually when we see a notch rolls, we are speaking about 30% binder, so cobalt, chrome, and nickel as a binder, and this is the perfect compromise to notch this roll and also to turn this roll. So we are speaking about turning because you can turn this material. But if you go lower than 20% as a binder, of course the turning is become very tough, and at that point it's better to change on a grinding machine. The geometry also and the shapes of the grooves that you need to machine is also another important factor to consider when you choose a lathe or a grinder. Why? Of course, a grinding machine can open limited grooves, limited depth of grooves, and also limited width of grooves. If you have if you have many different geometry and large profile, surely it could be better to consider a lathe. Of course, if the grade of the roll allow this choice. The mix also, as the geometry, is how many different profiles you have, and how many different tools you need to use. And inside this also we have the surface finishing, the metal removal rate, and the interrupt cut. There are another very important elements to consider. And the surface finishing, of course, a lathe can produce a surface finishing different from a grinder. Why? Because a lathe has only one cutting edge. You have a fixed tool that is cutting while the roll is spinning. Instead, on a grinding machine, the grinding wheels has thousands, that, as we will see later, thousands of cutting edges, and with that cut at higher speed and can reach higher finishing. But it's not always the point of finishing, because in some point of the mill is not so important the finishing as it could be, for example, on a high-speed block. In this case, of course, a grinder is better to be used for reach very huge finishing. The metal removal Also, the turning of tungsten carbide can be as just fixed parameters. Okay, you cannot change a lot. Instead, with the grinding machine, you can increase a little bit the speeds of the wheel. You can increase a little bit or decrease the speeds. So you have more room to move in this on this point. And the interrupt gap is another point that that must be spaced during the redressing, in particular of the rolls, because when the rolls are back from the mill, of course there is a remaining surface on the outside that must be removed. There are ribs to be removed, and as you know, if you have only one cutting edge, as you have in the turning lathe, could be difficult to have a good tool life. Instead of using a grinding wheel that with 1,000 of cutting edge, do not fear this kind of cutting. Therefore, with turning, we have these 4 elements that we saw before: the machine, the tool, the cooling system, and the parameters. About the cooling, just to start with in the middle, is not so important for the turning lathe, because usually you dry cutting for cast iron, for HSS rolls, and also WC is almost a dry cutting operation. Just a few air is blown over the cutting point to clean a little bit the chips produced by the turning, and to let it go, and to reduce a little bit the temperature of the tungsten carbide, but it's not so important like in grinding. The machine instead in turning is very important. You require an heavy-duty lathe with a stir, large bed plate. 4 guideways are the best in this case, like our machines, because you discharge better the forces of the cut on 4 guideways, not only on 2, as on classical parallel lathes. And this is good because you have the headstock and the tailstock of the lathe that is separate from the carriage. So from the cutting point is different, and the strength and the force that you reach during the cutting are better discharged on the bed plate. And the tooling is easier to select because you already use tooling like RCZX or RMGN that are round tools, round tips. And also for tungsten carbide, of course, you can choose a CBN, PCBN, or the diamond, the PCD, polycrystalline diamond. And this is a choice that you can do according to the cost, because CBN costs less than PCD, and it depends by the mix of the profiles, and also by the cost of the tool. Negative rake angle is just a suggestion to improve the cutting, and also the round honing on the cutting edge. We found that with CBN is important to have a cutting edge with an honing and 20 degrees approximately of cutting. So you have a 0, 20, 20 as a code for this tooling. And the parameters. As you can see here, I try to magnify a little bit. These are a standard parameter we suggest for turning. So 25 meters per minute, and means that with the rolls of 400 millimeters of diameter, you go at between 10 and 20 RPM. So it's is low cutting, as you know. The depth of cut usually is between 0.8 and 1 millimeter radial measure, and the feed also is 0.2 or 0.3. Is a very slow cutting because if you increase also the temperature on the tool increase and the life decrease exponentially. Okay. In grinding instead, we have the 4 parameters also here: the machine, the tool, and the cooling parameters. Speaking about the coolant system is very important in grinding because, as we see later, keeps reduce a lot the temperature that you have during the cutting, clean the wheel, clean the workpiece, and also cool down the workpiece, because also the WC, as you know, during the mill, along the mill, must be cooled down correctly to avoid any cracks or any modification to its geometry, to its physical composition. Therefore, it's very important to have a continuous cooling dedicated system to clean and to separate well the swarf, the remaining of the tungsten carbide from the water, from the coolant, and have also an high pressure and custom nozzle system to supply the cooling exactly in the area where the wheel is cutting. For the machine also here, you need an heavy duty CNC grinder, and so here a sturdy mechanical, and a high speed headstock for reaching the correct speed, for reaching the correct parameters. And also in this case, I indicated here the parameters is similar to the lathe, but we have here seconds. So you cut at 20 meters per second with 1,000 of diamonds on the same wheel. So no, it's not the 25 minutes per minute, but per second. So you understand the difference there is between lathe and grinding, and also the many more cutting edge you have with the grinding machine. Of course, plunge grinding and contour grinding are the two ways of cutting by grinding that we will see in the next slides. Okay, this is CNC machines. Here I show you the Atomat, the big grinder machine, where you can mount a complete composite cylinder for like this one, and up to 2 meters and up to 450 millimeters of outside diameter. And with this machine, you can also remove the tailstock and remove the steady rest and use the headstock for the rings. So this machine is perfectly capable of machining both cylinders and rings. And here you see the headstock where is mounted our wheels, and also you see here the tailstock and the headstock that keep the cylinder center to center. On the other side, we have also the lathe, and this is our mid-range lathe, also for section mill, and as you can see here, is 4 guideways, 2 guideways for the headstock, for the tailstock, sorry, and the headstock, and 2 guideways here under the covers for the carriage. This is also if you can see the bed here is large and not too high, so it's short and large. This is important also to keep to discharge the best the cutting forces. And this is the turning tool. This is just a quick view of the turning tool. This is our RNGN mounted on our fixed tool saddle. This is a heavy duty tool. Also, this here is our RNGN CBN solid tool insert that is cutting around the profile, the bar, I don't know, 20 or around that. You just need a tool that has a radius a little bit lower than the groove radius. And you see here the speed and the chips also. I hope you can see the chips that are going out. Are very small chips like powder, because we are cutting a powder material. And we use the blow of air just to reduce a little bit the heat of on the tool. Otherwise, this side of the tool will be very red hot. Speaking about grinding, we have 2 main processes now that probably you already know. Are the plunge and the contour grinding. Now, what is the plunge and what is the contour and the plunge? Contour is the way to create the pass profile by more passes at a fixed depth of cut. So the wheel moves along the pass and creates the final profile. Instead, with plunge grinding, you start with the wheel that has already the profile of the final groove, and goes in just one way, one direction, and creates the groove in one single direction. Here you see both videos On the left side, this is the contour. On the right side, the flange. Our machine can measure the wheel and can offset the wheel, so you don't need to do this by manual. And then on here you see on the left side the different passes you require with contour now to create the final shape of the groove. No? And in this case we have more than 10 passes, and while on the flange here you see the wheel goes straight and open the round groove. What is the difference here? Difference mainly is about the time you need, and also the grinding wheel you need for doing the two different processes. With contour grinding, we have 3 standard wheels, round 2, round 3.5, round 5, that you can use for opening every kind of profile. With the flange, instead, you need a wheel for each kind of groove. So you need a wider, bigger store for your wheels, but in any case, the time is 1/3 or 1/4 of the contour grinding. Therefore, many of our customers decide to shift to the flange grinding, so invest more on wheels, but reduce a lot the times for having their rings and rolls ready for the mill. And of course, after the process, it's very important also the tool that you use. So the wheel, this is, you can see here our our wheels, our electroplated wheels mounted on our machine. And here you see also the special nozzle that we developed in these last years with a round shape and with multi-nozzle that can put the coolant exactly in the place where the cutting is effective. Okay, and why we speak about electroplated grinding wheels? And we always use the electroplated grinding wheels also in past. Consider that Atomat since the 1970s. 1960s also we started to redress rolls for tube and pipe mills, rolls that were in tungsten carbide, and we started to use electroplated wheels. Why? Because the shape of the wheel is the same, the shape of the cutting shape is the same for all the life of the wheels. Therefore, you will have 50, 60 hours of continuous cutting, maintaining the same shape of the wheel without any need to redress, to dismount the wheel, to put on a redressing machine, and so to spend time to change. You have your power for 50, 60 hours of cutting. So you have thousands of diamonds cutting at this high speed, and making you spare a lot of time and a lot also of money in other machine, and in time of your operators to change to other machine. And how we do this wheel? We do these wheels in Italy for Atomat, and we can do this wheel with any kind of profile. So we do the body with the right profile of your finishing groove. For example, if we speak about flange, or if we speak about flange, we need to go straight, and we prepare the groove with the wheel. So the wheel is required to have the same profile as the finishing groove. And so in Atomat, we turn the wheel, we prepare the body, the steel body, we treat the body, and then we plate with the diamonds. As you can see here, there is a nickel layer, diamond grit that is placed with specific sides of the grit. And the calculation of the grit and of the body creates the perfect sides of the finishing profile of the wheel. Here on the left side, you see a magnification of the diamonds, of the synthetic diamonds, and the nickel that keeps them bonded together to the body of the wheel. And is used an electrolysis, so in a bath, and with the electricity, the nickel is melting, is electrically bonded to the wheel body. So the important points about the wheels are 6 points. There is a reduced overall operation times because the wheels is mounted and work for these hours, for 50, 60 hours without any change of the wheel or any operation required. The maintenance free, there is no redressing machine because with other wheels, with the metal bond or with the resin bond wheel, after some time you have to dismount the wheel to put on a redressing machine to use another wheel to remake the profile. You have to check the profile with the projector to see if the profile is correct, and then you can remount the wheel on the machine. Also, the consistency of the result is fixed for all the life of the wheel. For all these hours of cutting, you have the same wheel profile. So you just need a slighter correction on the machine if the interaction is a little bit out. You correct also with our probes, and then you go on without any other correction. Higher removal capacity, of course, because you have thousands of diamonds on the same layer. So you have no layers in where the diamonds are inside. So you have to redress and to keep out the diamonds. You have all the diamonds ready from the start to the end of the wheel life. The overall cost reduction for all these points, of course, also because the wheels are cheaper than metal bond or resin bond wheels, and also the reduced vibration. No need to balance the body wheels, of course, because the wheel body are already balanced when we produce them and are fixed. So there is no reduction in the outside diameter. So the body is stable for all its life and no need to balance with weights on the wheels. I don't want to speak too much about the metal bond wheels or resin bond wheel. I just make a quick comparison about between the two worlds. So metal bond wheels has the usually lower diameter than electroplated wheels. Our electroplated wheels are 350 millimeters of outside diameter. And I compared them in plunge grinding to see how many grooves I can do with the metal bond wheels. Of course, I have more grooves. For example, I can have here 416 grooves against only 150 grooves with the electroplate. But consider that the metal bond wheels can be redressed many times. So the number of redressing here, I calculated approximately 26. So removing 0.2 millimeter per each redressing, and gaining unit cost per groove of €2 and €2.04 against already €2 only for electroplated. But there is also wheel maintenance cost additionally you must keep in mind, of course, because I face this, but maybe one could be faster, one could be slower. There are some minutes to redress the wheel on an outside machine. And there is a cost, a unit cost for this that could be calculated, for example, in a total cost of redressing of a metal bond wheel of €700 approximately, to add to the cost of the wheel. And at the end of this journey, we could have more than 2 times the cost per groove of one metal bond wheel against one electroplated wheels. And consider also that electroplated wheels can be also replated. So you can put again the diamonds on them after the 50 hours of cutting you have. And the last point I want to delve in is the cooling system, because in the grinding specifically, the cooling system is really important. We developed the Aqua 27, that is a coolant specific for tungsten carbide grinding, because we tried many coolant, Mobile, Bactra, and so on, many kinds, many brands. So we wanted to have a coolant that that could have all the performance we need, not only for the cutting but also for the operators, because the coolant usually can be a source of bacteria, and Aqua 27 has been developed to reducing these bacteria, so to be also to be healthy also for the operators. So the cooling power is important in the coolant, like ours. The cleaning power, so the cleaning, how much the coolant can clean the wheel, the compatibility also with hard materials. So the coolant mustn't modify the tungsten carbide composition, because some coolant are very aggressive also on tungsten carbide, and then can create problems during the rolling mill, in the rolling mill process. Anti-foaming, mostly, as I told you, to avoid any kind of bacteria, and compatibility in particular with the hard water, because it's not easy to find soft water. So there are waters with a lot of minerals, and a coolant must work well also with them. After the coolant, it's important also the filtering of the coolant. Our standard system is the automatic auto cleaning system that we have developed in 1996 for radiable sludge removal. I mean, the sludge of the tungsten carbide goes inside from here, goes inside, and in this tank, in this system, the sludge goes down after the tank stops after a while, and let the heavy material, heavy particle of tungsten carbide goes and settle down, and there is this system of dredge, then moved by a mechanical system, by a motor and gears, and are removed from the tank from this site. This is a good system to filter the tungsten carbide initially, and we always supply this system included in our machines, in all our grinding machines. But after after years of study of what we saw around also the world, we saw that there is something more we can do to filter the tungsten carbide. And we studied a system with the multi-cyclonic filtering system. As you can see here, there is a basket here with 9 cyclones, and there are 3 tanks that separate the water, separate the coolant, the dirt coolant from the clean coolant. How is done this? All the material is collected in a tank of the dirt here, and then the pump load this send this coolant to the basket of the cyclones here. And inside the cyclones there is the separation between the particle of the tungsten carbide and the clean water. What was the challenge here? The challenge here is that the particle produced by the grinding are very small, and with the cyclone is not so easy to separate when you are under 5 microns of dimension. And in some cases we reach also 2 microns. So 2 microns, you get sludge with 2 microns of tungsten carbide. It was not so easy with only 1 cyclone or 2. So we had to develop a system with 9 microcyclones that in this case can cut up to 2 microns of dimension of the tungsten carbide. How it works is very easy. In this video is just a demonstrative video. The inside here you see is going inside the dirt coolant. Inside there is there's acceleration of the particle and of the coolant, and these particles moves down along the cyclone, and at the end of the cyclone, thanks to this centrifugal action, separates the hard particle and are collected at the bottom in this side of the cyclone. These are separated, but at the same time there is a flow through the top, where is the clean water that is discharged to the top of the cyclone. There is an outlet for the cleaning, for the clean water, and this is continuous. So the tank in this case goes cleaning continuously, and at the end we have a perfectly clean water that is reused to supply both the wheels, but also supply the cleaning of the grinding machine in its all. At the end, I put this case of study to compare the turning and the grinding, just to say that there is not only one solution. For example, this is composite. This is a composite cylinder with 6 rebar 20 grooves on tungsten carbide rings. We have 3 rings here, and we study how is the time to turn and how is the overall time to grind, both in contour and plunge. These are parameters that, and a case of study that I can give you also later after this presentation, so you can also look at the numbers and look at what we used to machine this cylinder. The turning parameters here quickly are the same as we thought before, 25 millimeters per minute. We use the turning tips, around turning tips. In this case, we use the RCGX 09 with V-seat, so it's very tough turning tool. And on the turning time, I calculate also the time to turn, also the spacer between the ring, the time for the pass, the time also for the rough and for the finishing of turning, because with turning you need to, of course, to make more passes also for the finishing. And at the end, we have a total turning time of approximately 1.9 hours. On the grinding side, of course, we do the flat grinding that requires approximately 91 minutes, because it's a slow process and you have to run on the overall barrel length of the roll. And then you see here the difference between groove plunging and groove contouring. The difference is that with groove plunging, you have the wheel with the rebar 20, and you go straight for 3 minutes. In 3 minutes you can open the groove, because we consider to remove 0.5 millimeter per minute in each speed, and remove a total of 0.8 millimeters. So we do not open from scratch the groove, but we cut 0.8 millimeters on radial. And in 3 minutes we can do the job for 1 groove. So for 6 grooves we have only 18 minutes. On contour grinding instead, the passes you have to execute are more than plunge, of course. And for 1 groove, you have 28 minutes against 3 minutes in plunge. You see the difference. It's different that we have 168 minutes for the contour grinding against only 18 minutes for the plunge grinding. And this is the difference you see. With the contour grinding, we go for 4 hours, considering the outside and the groove grinding, while outside plus plunge grinding, you have only 1.8 hours against 1.9 hours. You see here, the difference between turning and plunge are the same. So you can, in this case, I could say, okay, if I have the lathe, it's good to have the lathe, because I can cut with the lathe. But here, going again, all the factors that we spoke before for deciding if going for a grinding or for a turning lathe. This is the end of the presentation. I show you just a few numbers of Atomat that we had. For who didn't know us quickly, we are a group of companies present in Brazil, Slovenia, Spain, and Italy. And our headquarters is in Italy, where we produce rolls, CNC grinding and notching machine. The tooling for our machine are produced in Italy, like the grinding wheels, marking, notching tools. And the 4th plant has been started for the big turning lathes that we produce now also in our headquarters. Before they were in Milan with Jana. And in the last 2 years, we took over Jana, and now Jana is inside Atomat here, and we produce also our lathe here. So we have a good, we have a perfect side production here with all our products. This is the video. I hope that is smoothly running, and show Atomat inside, just to see that we have what we saw from the top. Okay, just a few numbers, then I finished the presentation. These are our distribution around the world, 70 countries and more than 680 machines installed and running around the world. And this is the increase during the years. Also in last year, we increased continuously. And in India, we have 41 machines in the main plants here in your country. Thank you. Thank you for listening. And now I go back to Vijay also. Vijay, if you have any questions, we can collect them and reply. Vijay, you are mute.
Thank you, Andrea, for this wonderful technical presentation you have shown to us. I am sure the attendees will be benefited in their day-to-day working life. Would you please take up the questions and answers, few of them, if possible? You can see them on question answer session, as well as you can read them in the chat also. You can pick few of them and answer them online.
Okay, I'm looking at the question. Okay, at the top, I mean. Okay. Okay, the prof. Is there any? Oh. Do you have any question collected during my presentation, Vijay? Because I see a lot of messages.
They are in the chat box, Andrea.
Ah, chat box. Sorry. Well, I'm not used to Zoom. That's why.
Yeah, because many of the questions have appeared on the chat box. People have continuously asked the questions.
Where is the chat box? Sorry.
in the bottom. Just
I see chat box only.
Yeah.
In the chat box, okay.
Okay.
I cannot find any. I think it's better to collect them later.
Okay.
Now, because I cannot find. I see chat box, but I cannot see any.
We have the record of these questions which are raised by many of the attendees.
Okay.
And we will answer them one-on-one after the webinar. We will be recording their contact details, and we will be answering to them. We will definitely take your help, and we will try to answer.
Sure.
Yes, possible.
If you make a list, I will reply to each one.
Okay. To all the attendees, we really respect your participation and your keen interest in attending this technical webinar. It was quite an interesting event. I see a lot of interaction happen during the session, both the session in Thomas' session as well as Andrea's session. People have come up and put up a lot of queries and questions. Unfortunately, because of the time limitation, we will not be able to answer all of them in one go. But for sure, Andrea, Thomas, and myself will look into all your queries, and definitely we will get back to you with our answers. In the end, thank you very much, everybody. It was our pleasure from the side of Pradman Engineering, and also from our panelists, Nextsense as well as Atomat. We sincerely thank all of you to participate in this event, and hopefully in the near future, we'll have a similar event for roll shop and steel rolling mill with a different topics. Thanks a lot from my side. Thanks a lot.
Thank you. Thanks a lot.
Thanks a lot from my side as well.
Okay, gentlemen, thanks for participating. And we are ending this session now. Thanks a lot. Bye-bye. Take care.